Good morning everyone. Today I will discuss about SPDF blocks, S block, P block, D block, F block elements. Yesterday I explained about S block elements, completely S block elements completed. Now today I will explain about P block elements. So according to classification of elements, according to differentiating electron. Differentiating electron means the last electron present in atom. So for example, if we take sodium atomic number 11, the total number of electrons present in sodium 11. The total number of electrons present in sodium 11. Hence 11th electron is known as differentiating electron. The differentiating electron present in s orbital, hence it is S block element. For example, if we take beryllium atomic number 4, that is 1s2 2s2. In beryllium also the electron present in 4th electron present in s orbital, hence it is also known as S block element. For example, if we take fluorine, in the fluorine atomic number 9, so what is the electronic configuration of fluorine? See, fluorine electronic configuration of Z is equal to 9, 1s2 2s2 2p5. See here 9th electron present in p orbital, hence it is belongs to P block. So based on differentiating electrons, the elements are classified into S block, P block, D block and F block elements. Yesterday already I explained about S block elements, and now about S block elements present in left side of the periodic table, P block elements present in right side of the periodic table, and D block elements present in middle of the periodic table, and F block elements present in bottom of the periodic table. Now about P block element, already S block completed yesterday. Now P block elements. The elements in which differentiating electron enters into p orbital are called P block elements. The elements in which differentiating electron enters into p orbital are called P block elements. In the case of example, see, I will explain example boron, simple example, boron atomic number 5. So here it is 1s2 electronic configuration, 2s2, 4 electrons over, 5th electron present in 2p1. See, it is p orbital, it is known as differentiating electron because it is the 5th electron. 5th electron is differentiating electron. The differentiating electron present in p orbital, hence it is known as P block. See, boron is P block element. So what is the definition? The elements in which differentiating electron enters into p orbital are called P block elements. The elements in which differentiating electron enters into p orbital are called P block elements. Understood? See here, generally, see, first point, the differentiating electron enters into p orbital are called P block elements. Generally in periodic table, the maximum number of electrons present in p orbital is equal to 6. The maximum number of electrons present in p orbital is 6. Hence P block contains 6 groups. So P block contains 6 groups they are 3A, it is known as 13th group, 4A, it is known as 14th group, 5A, it is known as 15th group, and 6A, it is known as 16th group, and 6A, C, 16th group, 7A, 17th group, and 8A, it is known as 18th group elements. Total 6 groups present in P block. Understood? 6 groups present in P block. Okay. See, the P block is the differentiating and electron enters into p orbital or P block elements. So here maximum number of electrons present in p orbital is 6, hence P block contains 6 groups. Generally the 6 groups means, for example, observe this, it is in the period table P block present in right side of the period table, that is P block in the right side. See, there is 3A, 4A, 5A, 6A, 7A. Okay. Okay, 7A and 8A. These are the blocks elements, 8A. Now, see, if you observe this, 3A group elements, generally 3A group elements are configuration, general electronic configuration, NS2 NP1. The elements are boron, aluminum, gallium, indium, thallium. 4A group elements are NS2 NP2. The elements are carbon, silicon, germanium, tin, lead. 5A group elements are NS2 NP3. That is, they are nitrogen, phosphorus, arsenic, antimony, bismuth. 6A group elements are NS2 NP4. Their total elements must be equal to group number. Understood? The total elements, the total valency electrons must be equal to group number. In the case of 6A group elements, 6 elements present, they are oxygen, sulfur, selenium, tellurium, polonium. And the 7A group elements are NS2 NP5. Total number of electrons must be 7. They are fluorine, chlorine, bromine, iodine and arsenic. And 8A group elements are NS2 NP6. They are 8A group elements, NS2 NP6. What are they? They are helium, neon, argon, krypton, xenon and radon. So these are P block elements present in periodic table. Because total number of groups present in P block, that is 6 groups. See, vertical columns are called groups in periodic table. Vertical columns, these are vertical columns. 6 vertical columns present in P block. 6 vertical columns present in P block like this. See, these are 6 groups. They have general electronic configuration also. 6 groups. The elements present in 6 groups in 3A boron, aluminum, gallium, indium, thallium. 4A carbon, silicon, germanium, tin, lead. 5A nitrogen, phosphorus, arsenic, antimony, bismuth. 6A oxygen, sulfur, selenium, tellurium, polonium. 7A fluorine, chlorine, bromine, iodine, arsenic. 8A helium, neon, argon, krypton, xenon and radon. These elements are P block elements. See, if you observe here, generally we know gaseous elements. What are the gaseous elements here? Nitrogen is gas, N2. Oxygen is gas, O2. Fluorine is gas, F2. Chlorine is gas, Cl2. All noble gases are gases. So here generally in the periodic table, total number of gas elements present in periodic table, 11 gaseous elements are present. 11 gas elements. So mainly gas element present in where? P block. The gaseous elements present in P block. So here P block elements are gas element means non-metal. Generally P block elements are non-metals. See the P block elements are see here non-metals present, and if you take germanium is metalloid, antimony is metalloid. Metalloids means they exhibits both metallic and non-metallic character. Both metallic and non-metallic character. So bismuth is pure metal. Bismuth is pure metal means the P block elements contains mainly P block elements contains non-metals. P block elements have non-metals and metals and metalloids and noble gases. See, noble gases. So P block elements are non-metals are there, metals are there, metalloids are there, and noble gases are there. So and another important point, P block elements forms ionic compounds and also covalent compounds, because if non-metal is there, non-metal can form ionic compound with metal. Non-metal can form ionic compound with metal, and non-metal can form covalent compound with non-metal. With covalent compound with non-metal. So here metal and non-metal forms always ionic compounds. Metal and non-metal forms ionic compounds, and non-metal and non-metal forms covalent compounds. So here many non-metals are present here, hence they forms both covalent and ionic compounds. And here noble gases are present. These are inert gases. They are not participating in chemical reaction because they have stable electronic configuration. Here in the case of noble gases, NH2 NP6. See, if observe NH2 NP6, no unpaired electrons are present. If unpaired electrons are present, they are participating in bonding. But here NH2 NP6 means no unpaired, because s orbital, see, the maximum number of electrons filled in s orbital is, see, the maximum number of electrons present in s orbital is 2, NS2, 2 completed. The maximum number of electrons filled in p orbital 6. See here NH2 NP6 noble gas. So no unpaired electrons. In the case of noble gases, no unpaired electrons. Hence they are non-reacting nature. Non-reacting nature. But remaining elements have unpaired electrons. To exhibit noble gas electronic configuration, they are participating in chemical reactions. In the participating in chemical reactions, to attain noble gas electronic configuration, sometimes they lost electrons, sometimes they gains electrons, sometimes they are participating in electron sharing. Based on their lost electron, gain electron sharing, the chemical bonds are formed. That is the main theory. So in the case of P block elements, I explained about P block elements, the elements in which differentiating electron enters into p orbital are called P block elements. The elements in which differentiating electron enters into p orbital are called P block elements. So P block contains the maximum number of electrons in P block is equal to 6, hence it contains 6 groups. They are already explained, 6 groups like this: 3rd A, 4A, 5A, 6A, 7A and 8A. They are also known as 13th group, 14th group, 15th group, 16th group, 17th group, 18th group. This is about P block completed. Now about D block. So about D block elements. In the case of D block elements, so same, the elements in which differentiating electron enters into d orbital, the elements in which differentiating electron enters into d orbital are called D block elements. The elements in which differentiating electron enters into d orbital. So differentiating electron enters into d orbital means, for example, if we take scandium, what is the atomic number of scandium? 21. So here 1s2, 2 electrons completed, 2s2, 4 electrons completed, 2p6, 10 electrons completed, 3s2, 12 electrons completed, 3p6, 18 electrons completed. After that, the electrons are filled in 4s2, 20 electrons completed. The 21st electron enters into 3d. It is 3d1. So here this is known as 21st electron is equal to differentiating electron. So 21st electron present in where? D orbital, that is 3d orbital. D orbital means that is 3d orbital. In the case of d orbital, the electrons only filled according to energy levels of orbital, already explained in atomic structure. After completion of 4s orbital, the electron enters into 3d. Why? The energy of 4s orbital, see, energy of 4s is less than energy of 3d. Energy of 4s orbital is less than energy of 3d. Hence, first 4s orbital completely filled with electrons. After completion of 4s orbital, the electron enters into 3d. So based on that, it is ns valence shell. It is n-1d. So in the case of all d block elements, the differentiating electron enters into n-1 d orbital. So here the definition, the elements in which differentiating electron the elements in which differentiating electron enters into n-1 d orbital are called D block elements. The elements in which differentiating electron enters into n-1 d orbital are called D block elements. The elements in which differentiating electron enters into n-1 d orbital are called D block elements. Okay, that is the first point. Second point, the maximum number of electrons. See, maximum number of electrons. The maximum number of electrons present in d orbital is equal to 10. Therefore, D block contains 10 groups. The D block contains 10 groups. They are starting from 3b, 4b, 5b, 6b, 7b, 8 3 groups and 1b, 2b. Total groups present in D block is equal to 10. The total groups present in D block is equal to 10. Understood? So here, but here it is about D block. Here 3b is equal to C. 3b is equal to third group, 4b is equal to fourth group, 5b is equal to fifth group, 6b is equal to sixth group, 7b is equal to seventh group, 8b is equal to 8th is known as 8, 9, 10. So these are three subgroups. These are three subgroups, and 1b is 11th and 2b 12th group. So these are according to numbers. So total groups present in D block 10 groups only, but it's 3 to 12 means 10 groups only. So here the elements in which the differentiating electron enters into n-1 d orbital are called D block elements. There are total number of electrons, maximum number of electrons present in d orbital is equal to 10. Hence D block contains 10 groups. They are like this 3, 4, 5, 6, 7, 8, 9, 10 and 11, 12. Understood? So but here the D block elements present in here fourth period and fifth period and sixth period in period table and seventh period. So n value is known as 4, that is 4 contains 3D series elements. The fourth period contains 3D series and fifth period contains 4D series elements and sixth period contains 5D series elements and seventh period contains 6D series elements in the case of D block. In the case of D block, here the 3D series means n-1 d orbital. Okay, see here about D block elements. Here D block elements contains 10 groups. They are present in 4th, 5th, 6th, 7th period. Understood? So today's class is over. Tomorrow I will continue same topic, D block elements. So effectively already I think everyone follows the class properly. It is very very important for objective in the case of for both foundation level of NEET and IIT advanced. Okay, everyone must follow the proper way based on your EDUHUNT material and EDUHUNT video classes. Okay, after seeing these classes, just prepare your EDUHUNT material. It's enough. Okay, thank you, and I will continue tomorrow same class.